Hello, everyone. My name is Alex Lewis. I am co-founder and CEO of Electroactive Technologies, where we are developing a modular system to turn organic waste and renewable electricity into hydrogen. The main problem we are addressing is food waste, which globally has an estimated cost of $2.5 trillion considering the economic, societal, environmental impacts of landfilling, which results in 8% of greenhouse gas emissions. The problem is also a huge opportunity to fight climate change and make renewable products, which is what Electroactive is pursuing through affordable, renewable hydrogen. Another problem we see is with the typical way fuels and chemicals, including hydrogen, are produced, which is in massive centralized plants with heavy emissions and long transportation distances. We feel a new paradigm is needed for a cleaner, brighter future. Electroactive takes a distributed approach and has developed a proprietary process using electron-generating bacteria packaged into a modular system, which can enable low-cost hydrogen production from waste on site or near site to work with large waste generators, haulers, and cities. Our underlying technology is known as microbial electrolysis and uses a highly active microbial biofilm to break down the liquid fraction of food waste into protons and electrons rather than methane, which are then used to make hydrogen at an electrochemical cathode. This two-chamber bioelectrochemical system allows us to make hydrogen with high efficiency and purity. We plan to launch in California, where food waste legislation and subsidies for low carbon fuels make for a very attractive market for our system. We can expand beyond California to the rest of the country and overseas as food waste legislation and hydrogen demand continues to grow. There's over 1 billion tons of food waste produced every year around the world, which could produce over $70 billion worth of hydrogen every year through our system. Finally, we are not limited to only food waste. Our technology is capable of converting all types of organic waste, including biomass, MSW, and wastewater, enabling us to produce even more hydrogen in the long term. So we plan to initially roll out our system to food companies utilizing fuel cell technology such as forklifts. Many of these companies are paying anywhere from $6 to $20 per kilogram of hydrogen, which is mainly sourced from SMR of natural gas, which is not sustainable, and supply is also unreliable as fuel cell users are not a high priority for the large gas companies. Additionally, these same companies can be paying anywhere from $50 to over $100 per ton for food waste management. Our system can enable more closed loop operations for these same companies, giving them an integrated waste management and hydrogen solution that can be deployed on site, solving two problems for them while lowering their carbon footprint and operational costs. We will utilize a service model to reduce the risk for potential customers and enable them to realize immediate savings, while we as a company can achieve a margin of over 25% with a 4-year or less payback period. The company can then grow to work with waste haulers and municipalities to tap into larger sources of food waste and hydrogen markets. Our system can be co-located at transfer stations or deployed at other strategic locations around cities to create a robust network as a local urban solution. To execute on this vision and scale up, we are assembling a very motivated and talented team, beginning with myself and co-founder Bija Barole. I helped advance this technology during my PhD, and Dr. Barole brings 20 plus years of experience as a scientist at Oak Ridge. We both spent the last 4 years advancing this technology, as well as developing the business strategy and company vision to grow our team and the necessary industry connections. Our advisory board also includes people coming from companies like Plug Power, Fuel Cell Energy, and Waste Management, with a total experience of over 75 years, which will expedite our path to market. Our company was originally spun out of Oak Ridge National Lab back in 2017, and since that time, we've secured an additional $2.1 million in funds to date and participated in a number of accelerators to advance the business, technical, and manufacturing readiness level of the company, while carrying out over 200 customer and partner interviews. Working with FedTech, the Innovation Crossroads program, and with support from TVA has allowed us to continue advancing the technology. We currently have a beta prototype tested for target performance and plan to carry out on-site demos at pilot scale later this year, with 2 projects in the planning phases. With our stack approach to scale up, successful pilot demonstration with a commercial scale single module can rapidly accelerate us towards commercial deployment. We are now raising $1.2 million, which will be used for additional team hires on both the technical and business side, as well as contracting for system design and assembly of the pilot unit in the actual execution of those planned pilots. Additionally, the funds will support further manufacturing plan and design development with an eye towards commercialization, as well as additional IP development and patent filings. Thank you for your attention, and I look forward to connecting and talking with anyone interested in working with us to realize our vision of a cleaner, brighter future. Thank you.
Hello, my name is Hisham Gosain. I'm the CEO of Endeavor Composites. We are a non-woven manufacturer that prides itself in processing defect-free, long fiber nonwovens that provide turnkey solutions for the advanced composite industry. All that through interception of landfill destined fibers. As you know, the composite market is on the rise, especially carbon fiber, where the demand is reaching 120,000 tons a year by next year. The only downside of it is that it's a 70% yield production, leading to 36,000 tons of excess fibers that are destined to go to the landfill every year at a value of $1 billion. The current approaches to mitigate that loss are milling, where fiber length attrition is a bigger problem. There is no mechanical properties and no financial value. Compounding for LFT, as well as some fiber length attrition, but it requires extra steps of processing and increased energy cost. So far, nonwovens have achieved a fiber length retention and low cost of production, but still in the area of carbon fiber, defects will be present when the fiber length goes above 12 millimeter or half inch. What sets us apart from other nonwovens manufacturers is that our patent pending process that can intercept these landfill destined fibers can create tailored nonwovens with the long fibers at high output, low cost, and defect free. These nonwovens are turned into turnkey preforms that can carry multifunctional properties and add $15 billion in value to the composite industry. In an apple-to-apple comparison, we were able to increase the interlaminar shear by 83% and the tensile strength by 52%, all thanks to no defect present in the fabric and the use of long fibers. Our business model relies on a business-to-business collaboration where we're setting strategic partnership with carbon fiber OEMs and composite recyclers. We process their excess carbon fiber into turnkey preforms for a plug-and-play application with the current industry setups and with tailored properties to each application, increased functionalities, and unlocking new potential. The market consumes carbon fiber in 4 separate sectors. For example, if we look at the automotive sector, only 11% of the carbon fiber it produces is in the nonwoven format. That is $100 million worth of carbon fiber every year. After processing into turnkey preforms, their expected revenue is nearing $600 million a year. So far, in the past 2 years, we're very thankful for several government agencies that help us raise $1 million in non-dilutive funding. That allowed us to expand our reach to industry engagement and create R&D projects with several major players. We want to thank our board of advisors for their deep expertise in technology commercialization and their guidance to us throughout the way. As well, big shout out to our strong engineering foundation, to the team of engineers and business professionals that have been my pillars in this journey. Last but not least, we strive to excellence in advanced composite manufacturing, thanks to our turnkey preforms technology that is defect-free, that adds $15 billion in value to the industry on full potential. It is eco-friendly, prevent fibers from going to the landfill. And all that is thanks to our excellent team of engineers and strong business professionals that help us raise $1 million in non-dilutive funding in our first 2 years. So far, we're always seeking paid pilots with market leaders, and we're fixing to raise a seed round starting in August. If you like to keep in touch, my email and phone number are listed on this page, and thank you again for your attention.
Great. Thank you so much, Hisham. We'll now open the floor for Q&A. Great presentation. Thank you.
Hisham, your slides look terrific.
Thank you, Jonathan. I appreciate you.
can you, first of all, you have to make this idiot proof for me. I understand that there's new material that has great application in automotive, in aviation, but you talk about the benefit of having something that's shorter than 12 millimeters. How does that fit in with a big panel of this material? I just don't understand.
Yes, it's actually the benefit of being longer than 12 millimeter.
Ah,
So there is a certain limit where we call it the critical fiber length. And in composite, all the energy have to transfer from matrix to fiber for the fiber to be functional in there, to have presence and take benefit of its strength. Below a certain length, which is normally in the vicinity of 1 millimeter, the fiber is useless. Its presence or its absence is the same. There is no load carried by the fiber. The longer the fiber it gets, the more potential you'll start unlocking the potential. So from this critical fiber length, you start using the fiber and its full potential is used when you reach 1 inch long. And that's what we were able to achieve in discontinuous performance. Using the full performance of the fiber put us in close vicinity to continuous fiber production. And why this is important is that because in continuous fibers, when you look at a part where the fiber is from beginning to end in one single strip, those are very costly. They're expensive, especially in the carbon fiber field. Raw carbon fibers start at $20 a pound for that material. We were able to bring down the cost by at least 75% and still keep the performance close in the 70% of that continuous fiber by using the longer fibers.
and is this based on your finding, or there's actual market demand for existing use cases?
No, this is an actual market demand. It's everybody's been trying to seek how to handle discontinuous fiber at a longer length, just because scientifically it's been proven to provide the better performance and better handleability. And as I mentioned, there was other approaches with long fiber thermoplastic pellets. The problem is through processing, they shorten the fiber again. And we've been competing with that.
Okay, sorry, I just don't want to take time from the other panelists.
Hey, great presentation. I think there's a lot of uses for this. I just wanted to clarify something. So you said it's a turnkey solution that can intercept a lot of that waste. Something I might have just missed it, but is this a solution where is that waste leaving the facility to be processed on your side at all, or is this is it plugged into their system, it's intercepted, and then they can just recycle it on site to continue production?
It can be done both ways. We can collaborate with the carbon fiber OEM. The production, the early stage production or short spool can be shipped to us, or we can have our system within their facility and just processed immediately without having to worry about shipping. The idea here is that those fibers are not recycled fibers. They're virgin fiber. They're still a pristine fiber that hasn't been used. And because of the nature of the early stage or short spool, that doesn't fit the weaver's manufacturing, because weaver require a specific spool size and weight for their system to stay continuous. Companies couldn't process these fibers, but they're still a virgin high quality fiber that we can process. On the other side, for recyclers, all recycled fibers is a short fiber, so they can ship it to us, or we can build a facility right next door to them, have our equipment there to process on site.
Okay, great. Thank you. Appreciate the clarification.
No, thank you.
Hi, Jean.
Hello.
I will say this probably to all the teams, that I really congratulate you a lot.
Thank you.
Sending hugs from Florida. I mean, it's this is why I want to be a mentor. So I enjoy every bit of this. So you see, I have a quick question for you, but before that, I want to actually stress on something that we are seeing here in the innovation Crossroads, particularly also with this cohort and the previous cohort in somehow. So these guys are taking things from the environment. In this case, for example, if this goes to landfill, it will be there forever. And they are processing it in a way that you can reuse it, and they are creating even better materials from and better technologies in the case of the energy for that. And that is so commendable. And that is a really great thing on the whole, not even recycling thing. I mean, on the self-sustaining economy. So this I think that in your case, for example, this is an awesome way to do it. In a way, I can say that you are creating even better materials from the waste of your competition. So it's kind of like that. Compare non-woven with woven and so on and the thing. My only question, I mean, you did great. My only question is that how far are you from mass production? What do you still need? I mean, the partnership that you need to do. How is it going? Because I see that I think this is a great business.
Yes, thank you. Thank you again for highlighting exactly what our mission is in creating a better, more sustainable economy, especially on something that's high risk for the American safety and national security, such as carbon fiber and its applications, from energy to defense. Right now, we have built a pilot line that's operational on a larger scale. We demonstrated that we can scale up the mixing from a lab scale to a pilot scale. It's still a semi-continuous production, and that's where we're going with the seed round in order to scale up to a more of a manufacturing scale. So the full manufacturing scale with the lead time will be ready around August 2022. In the meanwhile, with our semi-continuous pilot, we can conduct more low volume production for making parts already, but sadly it have to be a low volume for the next year. And we're hoping by next year, once the commercial line is fully set up, we will be able to process close to 20 million square foot a year. And on full scale potential 40 million square foot with that machine. And that will allow us to produce high volumes and faster production and collaboration with industry.
Awesome.
Hisham, I'm not sure this is a question. Let me call it a confession. Some people put in addressable market values in the billions and people's eyes light up. I'm the opposite.
Yeah.
I like to see a really nuanced approach to getting at the low-hanging fruit first.
Exactly. Sorry, continue.
No, go ahead. That's fine if you wanted to respond.
Sure. I'm with you there. I'm always been encouraged to show the bigger picture. And at the same time, as an engineer, the engineer in me goes picking like, realistically, you're not going to make $1 billion next year. But the beauty of this system and the partners we've been working with is that they are a high volume production. So past the validation and certification phase, during this phase, maybe the first 2 years, making $10 to $100 million, I'm going to be a very happy camper. And that's why I highlighted like the automotive section alone, processing 11% of the fibers at $100 million worth of carbon fiber. So you add the processing fee and margins to it. But then everybody's producing high volumes. And with the high volumes comes immediately like a multiple increase. It looks like a hockey stick rise. So our goal that hopefully in the next 5 years, we'll reach the $1 billion.
Great answer.
That's not immediate. It's not going to be the next 6 months, sadly.
Yeah, okay. Congratulations.
Thank you.